All right. So our next topic here, as it says, this is the work plan. So circular functions. So it has to do with sine, cosine, tan. If you have a look down here, sine, cosine, tan. Now we've been using sine, cosine, tan for a few years now. So this here really gets down to what the definition of it, where these sine, cosine, tan actually came from, where they were defined. And so we're just looking at very briefly the first part of how they're defined, etc. Now, there's also, so if I come to here, so this is what we're talking about. We've got is, so it's circular functions. All right, so it all relates back to what we call a unit circle. All right, and a unit circle, what is it? It's a circle of radius 1. All right, so 1 unit, whatever that might be. All right, so that's what we've got, a circle here, a radius of 1, and so all these things relate to that. So if we then put our unit circle on a set of axes, and not any random set of axes, but a set of axes where the center there is at the origin, so on a set of x and y axes, and then we could do a whole bunch of things. All right, before we get to that though, there's a couple of different ways that we can measure angles. All right, well, there's more than a couple actually. All right, so measuring angles, degree, radian, and then there's a third one called gradient, and we are not going to use the gradient. Surveyors use that a bit and those kind of things. So the ones we're used to at the moment, we know that degrees. We know that a circle has 360 degrees in it. So what is this radian? All right, so this radian, let me bring up my, here we go. So here, for example, so here we've got 40.09 degrees. We've got a circle here, 1 unit. Okay, so remember that's what we're looking at, 1 circles of 1 unit. And it's telling us that the arc, so this length here, is 0.7. So if I take this and I drag this, that changes my angle in the middle and changes my arc length. So I'm going to come around here and I'm going to go up here. Keep going. Let's arc of 1. So in our unit circle here, that's a length of 1 around there. Now in degrees, this is 57.32 degrees, but we could also use the distance around the arc as our measure of the angle as well. And so the distance around the arc of a circle of 1 unit, when we've got 57.32 degrees there, is 1. So this angle here, we've talked about it here, is 57.32 degrees, but we could also say that it's 1 radian. All right, and if I keep going, all right, 90 degrees, 1.57. And I keep going around here, 180 degrees. Can't get it just straight on. Oh, just close, 3.14. That's interesting, 3.14. All right, what's pi? Okay, and keeping going around, and so as you can see, 326.92 degrees, arc length 5.71, so we could say that that is in radians 5.71. All right, so clearly there's got to be some sort of relationship between the two. So remember, this arc length is the distance that we're traveling around a circle. Now, if we go the whole way around a circle, 360 degrees, there we are, all the way around here. It's calling the arc from this length is 0. So it doesn't like me being right there. Thinks I've just jumps. All right. So it's gone back to 0. Won't let me do 360. All right, 6.27. All right, so the distance around the outside of a circle, so let's go back here. Back to here, so we've got a unit circle. Circle we got is our radius is 1 unit. And our distance around our circle would be what we would call a circumference, wouldn't it? And circumference of a circle is 2 pi r. So the circumference around the circle in the radius of 1 unit is 2 pi times 1, which is 2 pi. So what's that saying? Well, that's saying if I come back to here, what it's saying is for this circle here of 1 unit, that distance around that circle, which is the arc length, is 2 pi. Now, in degrees, it would be 360 degrees. So in radian, so let's go here, I'm going to say, so in radian, for a whole circle, so a full circle, is 2 pi. And we put this little c up the top, and so that indicates radian. Okay, so when you see that written, sometimes it's left out, sometimes it's in there. All right, I'll talk more about that in a moment. But if in degree, a full circle would be 360 degrees. So from that then, 2 pi radian has got to be equal to 360 degrees. And if we divide both sides by 2, then pi radian has got to be 180 degrees. And so we can use that for when we are doing conversions. So if we want to do a conversion, and our conversion we want to do is, let's go from degree to radian. Then what we do is we take our angle in radian will be our angle in degrees divided by 180 times pi. All right, so we're going degree to radian. So we take our angle in degree, divide it by 180, times it by pi. And there's different ways that you could write that. Alternatively, and probably often you see it's times pi on 180. All right, and then, so if we want to go the other way, to degree, then what we would do is to get our angle in degree, we take our angle in, oops, that should be a degree there, take our angle in radian, and we divide it by that pi on 180, which often you will see written as 180 over pi. All right, so let's have a look at an example, or a couple of examples. So convert 30 degrees to radian. All right, so that's this one up here. So to get it in radian, we take the degrees, which times by pi on 180. So our angle in radian is 30 degrees times pi on 180. And 30 goes into itself once and to there 6 times. So 30 degrees is the same as pi on 6 radian. Now, sometimes you see the C there, sometimes you don't. All right. So if we wanted to convert, say something, so convert, whoops, so convert 45, no, not 45, pi on 4 radian to degree. And then the angle in degree was our pi on 4 radian times by 180 on pi. The pi's cancel. 4 goes into itself once and into 180 45 times. And so our angle is 45 degrees. All right, so that's that in terms of the degree and the radian. And so remember that the radian measure is the length of that arc of a circle of 1 unit. Now we can expand our circles out to as big as we like, just using a scale factor, but the original definition of it comes back to that unit circle, as does the next things that we're going to look at. And so these next things we're going to look at are sine and cos. Now we've been doing sine and cos for a long time. We've been using them, opposite over adjacent, stuff like that. So here I've got a circle, again a circle, unit circle, 1 unit here. And so here it says this is 52.91 degrees. So by definition of where the sine and the cos came from is this. Now I'm going to move that, get rid of those for a second. So we've got a point here which has an x and a y coordinate, and the x coordinate is our adjacent side length, this side length here. And remember when we're looking at adjacent and hypotenuse, remember that's cos. Well, this is where it comes from. This length here, this 0.6 length, that is the cos of 52.91 unit circle. All right, make the circle bigger, then this side length is related to the cos of the angle, but when it's a circle 1 unit, it is the cos. And the same, the opposite and hypotenuse, remember they are sine. And so here's our opposite, this blue one, which is the y coordinate, and this length of this side here, which is opposite, so it's the sine. And in a unit circle, that length there is the sine. All right, so we better write that down. So let me scroll all the way back down to here. So we've got our unit circle. So we've got a radius of 1 unit. We've got a point here. X and Y. Let me change my color. Then this length there is our cos theta, and there's our theta in the middle. Let me change colors again, and this length down here is our sine theta, and of course there's a right angle there always. So that's for our unit circle. So sine theta is this length here, and this length here is in the y direction, is the y coordinate. This one here of unit circle. And let me change my back to orange. And cos, I'll write that up there. So, maybe you can scroll just a smidge. Yeah, I'll have to squeeze it in. And cos theta is the x coordinate. Unit circle again, of a unit circle. All right, and so that is that one there. All right, so that's the definition. So that's where it comes from. So that's where they were defined. If you make your circles and bigger and your triangles bigger, then these lengths get bigger. And then what comes into play then is those trig ratios that we used to. So let's say, for example, I'm gonna let's say, for example, I say this. I say, all right. So what is the following? So I'm going to say, find the sine of -3 pi on 2. Okay, so first of all, and I haven't, it's a bit wonky, and I haven't actually talked about this at the moment, so let me do that now. So something we can keep in mind here, this is a unit circle, so if that's a unit circle, then the coordinates of that point there is 1, 0. The coordinates of this point here is 0 and 1. The coordinates of this point here are -1 and 0, and the coordinates of this point here is 0 and -1. All right, so the pi's on 2's, the 3 pi's on 2's. Now there's some equivalent angles. So remember I said for a whole circle, so for a whole circle, let me change this color. So for our whole circle, so a full circle, we've got 360 degrees, and it's the same as 2 pi radians. Yep. So 180 degrees then would be pi radians, and then 90 degrees would be pi on 2 radians. All right, and so here in this one, we've got a negative, and normally, and I didn't mention this either, and I should have, normally, so for a positive angle, positive angles, we go anti-clockwise. All right, so from our positive x-axis. All right, so that's here. We're always measuring our angles from this line here. And so for positive angles goes that anti-clockwise. So for a negative angle, we go clockwise. All right, so that's the negative. So this time we're going to go that way. So the 3 pi on 2, 3 pi on 2, another way I can write that is 3 lots of pi on 2. So if pi on 2 is the same as 90, 3 lots of that would be 1, 2, 3, around to here. So this angle there that I've done is negative 3 pi on 2. All right, so the question is, what is the sine? All right, so from up here, what we mentioned, that the sine is related to the y coordinate. So the sine is related to the y coordinate. Y coordinate of where? The y coordinate of this point, because there's our angle, where our angle ends us, up around here. And where it ends up here, so we're going through there. There's our point. Our y coordinate is 1. So it's all a bit messy, but anyway, I'm sure we'll survive. Back to here. So the sine, let me write it down there. So the sine of negative 3 pi on 2 would be equal to 1. All right. And so in the exercise that we get to, sometimes we've got to do using our calculator. So let's have a look at our calculator. So you might do it by hand. And so here's one where we can do our calculator. It's all right. So let's say do this. Evaluate the sine of 1.9. Now, I mentioned before, there's a fair bit, that sometimes you see the radian sign, sometimes you don't. And so the convention that's usually followed here in Australia is to not write it. So if you see something like this with no sign there, it's in radian. Okay. Always, and this is the way VCAR does it, always, 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 if it's degrees, the degree sign is there. So if it said evaluate, 36, cos, and it had a little degree up there, it would be degrees. But if it said evaluate, cos 36, and no sign up there, then that would be in radian. All right, so we wanted the sine of 1.9, so let's go to our, oh, I haven't opened it up. Let me open the calculator. So sine of 1.9, we need to, down here, rad, we make sure we're in rad, go to our keyboard, sine 1.9, and EXE, because I've got it in standard, it doesn't give me the number. Okay, it just rewrites it. So I need to put it in decimal. EXE, there it is, 0.946. I'll write that down here, equals 0.946 to 3 decimal places. So there we are. There's how we'd use our calculator. All right, now there is another function, sine and cos. The other one is this one, tan. So here's our unit circle again. Here's our point. So there's our x and our y coordinates, right? So tangent. So there's our triangle. So there's our angle in the middle. Radians. Remember, it's a unit circle. All right, unit circle. So that's the distance around the outside. It's just easy to mark it in here. So it's the radian is that length around to there. All right. So unit circle. Right. Turn that off. Turn that triangle off at the moment. Show the tangent. So the tangent that we're talking about, there could be tangents all sorts of places around that circle. One we're talking about is this one here. the one that touches there. And so if I then extend this, you can see through that point reaches the tangent there. So the tan value, by definition, is this length from there to there. So triangle 2, there it is, triangle 2. So this side length here is the tangent. And there it is. It's 0.94. So if I change that, that tangent value changes accordingly. And if I turn back my other triangle, so you'll see now we've got two triangles. All right. All right, so it's the length of the tangent that we're interested in there for tan. Now, interesting, we've got two triangles here. And our two triangles, our blue one, notice that length's 1, and this is our tangent up there. And the red one, we've got that length there and that length there. Side lengths, the angle I should say, is the same. So the ratio of this side to this side is the same as this side to this side. So what am I talking about? So let me go back here to the blue. I need some more paper. Let me get some more paper and bring up enough paper. Where are we? Right, let's use this bit of paper. All right, so I was waffling on here. So my blue triangle, that length here is my tan definition, so tan of my angle, and it relates to this, which is sine of my angle. So the length of that side divided by the length of that side. That's what I'm going to do. So it's the tan of my angle. Oops, haven't turned my pen on. So tan of my angle. So tan of theta divided by sine of theta. And because they're similar triangles, one's bigger than the other, then that ratio of those two side lengths, this one and this one's got to be the same as this one and this one. So one of them, the blue one, because it's a unit circle, that's a length of 1. And the red one here, well, that's cos. And so going back here, so that's 1 over cos of our angle. Now, if I multiply both sides here by sine theta, then it cancels there. And so we have this other expression that tan theta is also sine theta on cos theta. All right, so we can get tan theta in two different ways. All right. All right, and so that's your tan. And the last thing on this particular one is what we call symmetry properties. Now, if I come to this particular one, you'll notice there's a whole bunch of angles. So you can see this angle in here. All right, here's our sine and our coses. There they are, 30 degrees. There, pi on 6, it's shown is the equivalent. And there they are there. Now, if I come all the way around over to here, 5 pi on 6, for example, you'll notice, have a look at these. I'm not quite on it. There, now I'm on it. 150 degrees. So you'll notice these values. And you'll notice here they've got this grade circle. And have a look at our coordinates. They're the same. Why are they the same? Well, if we make this triangle, and we're always making this triangle back to the x-axis, these two triangles are the same. But now we're across here in the negative direction. So that's why our cos here is now negative. If we keep coming around down here, again, these two triangles are the same. So these values are the same. But now we're down below, so that's negative. We're down here, that's negative, and so on. So when we talk about, and then there's the fourth quadrant one there. So when we're talking about symmetry properties, that's kind of what we're talking about. We're talking about, and we're going to delve into this far more deeply later. What we're talking about is we're talking about angles in other quadrants that relate back to one in the first quadrant here. And so if we like to have a look, and you have a look at these numbers here, so let's go to that first quadrant one, and I'm just going to use these ones. Notice these are both sine and cos both positive. Over in the second quadrant, cos is negative, sine is positive. In the third quadrant, they're both negative, and given what I said before, that tan is sine over cos, a negative over a negative is a positive, and then around here in this last one, the sine is negative. All right, so what we can do is we can come up with a little bit of an acronym thing to help us figure out. So all will be positive, sine is positive, so the other two would be negative, tan is positive, and cos is positive. So A, S, T, C, all students talk crud. All right, and that will help us. So that's what we talk symmetry properties. So let me have a look at some examples. Oh, I need to open another one. There we go. Let's have a look. So if, for example, I need to turn on the thing. So if sine x equals 0.6, so x is some angle, we don't know how big it is, find sine pi minus x. So the way I would always do it, here's my unit circle, sine x. So if this is x, there's my x. And the sine of x, that's that length there, is 0.6. This is a unit circle, so that's 1. Now let's have a think about this. Pi minus x. So, as I said before, what we do is we measure in the positive direction. So pi minus x, so positive is in the anti-clockwise direction, minus x, so we've got to go minus x back to here. So the angle that we're looking for is actually this angle in here. Now what's significant is that that angle in there is x. And through that symmetry that I talked about before, then our pi minus x, and that then is x, then this length here is the sine of pi minus x, and that's a radius of 1. That angle and that angle there are exactly the same, so even though my drawing doesn't show it, this side length and this side length must also be the same. So the sine of pi minus x is 0.6. All right, so I'll just do that, just that one example, but it's the same process, and you should get used to that process because you use that process for every single angle. There's a list of relationships, but there's a big list, and that's a lot to remember. Whereas that process that I've just been through there, you can use that process time and time and time again, and you don't need to remember too much. All right, I think I've waffled on for long enough now, so have a crack at that stuff, see how you're going. Of course, if you need help, get back to me. All right, so have fun.